Okay, we're in section 13 of the notes, and we're going to do the examples now. So we go to the examples. And of course, when I'm doing the examples, I encourage you to also, write down what I'm writing. If it goes too fast, though, you can always come back and watch this at a later time. But the bottom line is you want to be able to understand what we're presenting so you can have a chance to do it on your own. And where's that going to come? After the examples, you'll see some homework problems for you to try. All right. So I'm going to switch screens. And I'll switch screens to my whiteboard. Certainly, I'm going to read the question to you, and then I'll go about doing the question as asked in the word. It says, find f prime using the product rule. Well, to do the product rule here, I'm going to write this down as a product. So what's the product going to be? It's going to be e to the x times e to the x. So f prime is going to be equal to, let's take a look at this. It's going to be the first function times the derivative of the second function, which is e to the x, plus the derivative of the first function, which is e to the x, times the second function, which is e to the x. Kind of remarkable. What do you get? E to the 2x plus e to the 2x. These are like terms. Add them together. What do you get? 2e to the 2x. Look at the key. Make sure the key says that, and it does. That number one is done. Let's go to number two. And number two is, sort of related to number one, right? And this is typical. We have problems that are related to prior problems, and that's why you should go on order in the homework. So over here, what I'm going to do is I'm going to use the quotient rule. So f prime, f prime of x, what do you do? Well, order matters here. So I'm going to be pretty consistent, at least I hope I am. I'm going to square at the bottom, bring the bottom to the top, times the derivative of the top. The derivative of top is going to be minus 1 plus 2x minus the top. That goes in parentheses, 1 minus x plus x squared times the derivative of the bottom. Well, we just did that. And what's that going to be? 2e to the 2x. All right. Now on exams, this is not all teachers, but I would say, gee, good job. You did find the derivative. Our goal, though, is to simplify these guys. And why is that? We have to use them at some point. Now, right now, this is an unusable form. What I'm going to do is I'm going to divide top and bottom by e to the 2x. And what would you get? Well, the first term on top would become minus 1 plus 2x. The second term, again, I'm dividing the second term by e to the 2x. What would you get over there? You get 2. On the bottom, one of the factors would cancel off, and you get e to the 2x. I'm going to simplify that. You can get minus 1 plus 2x minus 2 plus 2x minus 2x squared over e to the 2x. Let's continue to go forward. We'll look at the key later. So I'm saying, excuse me, minus 2x squared plus 4x minus 3. You could put a box in that one over there. Simple. I will say that most textbooks would factor out the minus sign. Minus, this would be 2x squared. Minus, whoops, that's 4x. Sorry about that. 4x plus 3 over to the 2x. Now, I said I factored out the minus sign. Notice it's minus 1 over there. I'm going to erase the minus 1, which is really what I factored out. I just put minus 1 over there. A minus sign over there. So let me erase this over here and put a minus sign here. Okay, let's look at the K, and there's always a possibility of making a mistake, and that's why we want you to look at a K. So what do you get over there? Well, we got the final answer, which is a simple form of it. Again, let me point out, I'm the kind of instructor that would accept this as an answer, accept this as an answer, and certainly accept that final form as an answer. They're all good to me. All right, let's look at number 3. It says find the derivative, and this is a section on product rule and quotient rule. So I'm going to write down f prime. What's nice about the product rule, you could do it in a different order and still get the same answer. So it's going to be the first function, which is 4 e to the x minus x squared times the derivative of the second function, which is 3x squared, plus the derivative of the first function, which is 4e to the x, minus 2x times the second function. Again, I'm of the opinion that this is a good answer. I would give you credit for that. I do want to go through the simplification now. And the reason for that is that, typically most textbooks would simplify this and most teachers would demand a simplification. So what do you get? I'll write this down for you. You get 12. I'm using the distributive property multiplication, x squared, e to the x, minus 3x4. Let's keep going. A little more complicated now, isn't it? So plus 4x cubed e to the x minus 20 e to the x minus 2x4 plus 10x. All right, let's write this down. And I'm going to, look for high powers of the, I'm going to do the e to the x's first. I'm going to say this guy's a leader. You look at the key later. Then I say, follow this guy over here. Let me see if that's true. Yeah, I guess so. So plus 12x squared e to the x. And then I probably say minus 20 e to the x, right? I'm following along with the e to the x's. And now let's put the that polynomial down in order, by the way. So it's going to be minus 5 x to the fourth. I'm seeing that here, plus 10x. All right, put a box in that. And again, my encouragement to you is please look at the key. And when I'm looking at the key, I'm seeing 4x cubed e to the x plus 12x squared e to the x minus 28 minus 5x4. Yeah, we did all right. All right. So let's do number 4 now. And number 4, I would use quotient rule. So f prime equals, and again, I'm going to do this in order. I'm going to square the bottom first. Bring the bottom to the top. Times the derivative of the top, which is 1, minus, again, the top, which is x, times derivative of the bottom, which is 6x. I will accept this on the exam as the correct answer. I do want to simplify it though. And then we'll look at the k. Whoops, forgot something there, didn't I? 3x squared plus 1 squared. And then what do you get on top? You get, let's see, 3x squared minus 6x squared, which is minus 3x squared. And you get a 1. I'm going to say it's a simple answer right over here. So let's take a look at the k, see if we got it. And I'm seeing it, all right? And you want to match these answers as well, all right? Maybe not initially, but you do want to practice your algebra skills to go forward. Let's go to number 5. And number 5, they want me to get the derivative of this guy over here. Now, by the way, someone's going to say, how are you going to do this problem over here? Well, I first have to find a derivative. So let's write that down. Fairly simple, square the bottom. Bring the bottom to the top. Times the derivative of the top. Well, the derivative of, root x plus 1 is 1 over 2 root x. That's pretty simple. Minus the top times the derivative of the bottom, which is 1 over 2 root x. You don't have to simplify it. That is the derivative. And again, if that's an exam question, you would certainly get some credit for that. What I want to do, though, is I want to do what they asked to do, which they want me to do f prime of. Again, if you can't remember, that's why I write things down for you, 4. All right, the way I would do that is I wouldn't do it in simple form. I'd do it in the form I got over here, because this is my final answer now. And what are you going to get? Well, on bottom, what do you get? The root of 4 is 2, and 2 minus 1 is 1, and 1 squared is 1. That was easy. Let's go to the top. What do you get? The root of 4 is 2. 2 minus 1 is 1. Times, this would be 1 over, 2 times the root of 4, which would be 2 times 2, which is 4. Minus, right? The root of 4 is 2. 2 plus 1 is 3. And then you get 1 over 2 times the root of 2, a root of 4, which is 2. So you get a quarter. So things look like they're working out pretty nicely. What do you get? 1 quarter minus 3/4, which is minus 2/4, which is minus 1/2. All right, let's look at the k, and they got minus 1/2. I also notice they simplified the derivative, so I want to go through that with you. And the way I would do that is I would multiply top and bottom. Oh, geez, what would I do? Probably multiply top and bottom by root x first. I'll go through that. Again, a lot of students say, do I need to do that? You know, it's up to you what you want to do, but I want to point out the more work you do, the better you're going to get at this. So let me go through that with you. What's f prime going to be? And again, I'm going to write this down for you. You know what? I'm going to do 2 root x. Excuse me 1 second, get my eraser out. And the reason that's what's called the minor LCD that you learn about Math 100. So we're going to take top and bottom by 2 root x. What do you get on bottom? 2 root x times root x minus 1 squared. What do you get on top? Root x minus 1 times 1 minus, well, you get root x plus 1 now. All right. Let's see if we did that right. Yeah, I think we did pretty good. So what do you get over here? Well, let's write this down. Oh boy, that looks like pretty tough, doesn't it? The top is easy though. It's root x minus root x minus 1 minus 1, which is minus 2. There's a 2 there. I'm going to reduce that. That would be 1. And this would be root x times root x minus 1 squared. By the way, I would say that's my favorite answer right there. I want to claim, though, a lot of times what happens when you're looking at an answer key, which I hope you have access to, the answer key that I'm providing you, that you certainly want to be able to match their answer as well. Now, we've already done this part. I'm looking at their answer, and I'm not matching it. So I'm a little concerned about that. So I want to go through this. I want to continue to work on this. And what would you get over here? Let's write this down. I can multiply top and bottom by root x. All right, what would you get over there? Oh boy, that looks like it's a tough one, doesn't it? So it's going to be root x. I'm multiplying top and bottom by root x, by the way. You would get x. And I'm going to expand that guy. What would you get? X minus 2 root x plus 1. All right, I'm going to go back and look at the answer. And notice I'm still not matching the answer. All right. So what I'm going to do is I'm going to back away. And someone says, why would you do this? I want to see if I can get it. So I'm going to start to erase. And this is going to be your struggle. And I'm going to start to look at this problem over here. And when I look at it, I'm going to write a little bit differently. Again, my goal is to match the answer. I'm going to write this as root x minus 1, and then root x minus 1. This is why would you have done that? Well, my goal is to match their answer. And it looks like what you're doing is rationalizing the bottom. So let's go through that. I got to get my eraser out because I made too long of a bar there. So I'm going to multiply by conjugates. And what do you get over here? Well, root x would certainly be one of them. And then I'd get root x plus 1, root x plus 1. You're going to learn a lot by matching people's answers, by the way. So what do you get? Well, let's put this down. On top, what do you get? You get root x plus 1, root x plus 1. What do you get on bottom? Well, I'm going to do some associations to a commutation. So I'm going to associate the root x with the root x. I would get x. And I'm going to associate the conjugates now. What would you get over there? You would get x minus 1. Again, we're associating these two. Then we just associate these two. And then when I associate these two, what do I get? X minus 1. So what do I get? Let's go through this in the bottom. You would get x times x minus 1 squared. This is what's known as rationalizing the bottom. The bottom's nice polynomial now. What do you get on top? Well, I'm going to go through it with you. You get root x, and root x times x is x, plus 2 root x, plus 1. I'm going to multiply that out, and I'm hoping I'm matching the answer at this point. So what do you get? X, root x, plus 2x, plus root x over x x minus 1 squared. Again, we're just practicing. That's all we're doing. Let's go back and look at the answer they got. And they got x root x plus root x plus 2x. Yeah, we did good. All right. I want to point out, I would not be doing that in the exam, by the way. I really wouldn't. What I'd be doing in the exam is I'd be putting the derivative really quickly and evaluating the derivative really quickly as well. I would spend a lot of time simplifying things. However, if something's easy to simplify, I strongly suggest you do that. And the more you practice this, the easier this will become. All right, let's take a look at this one over here. This is number 6, and number 6 is asking for the derivative. So let's write this down, 6 f of x. I'm going to write this as a quotient because I know about the quotient rule. Let me put its derivative down. Should be fairly simple to do if I know the quotient rule. That would be e to the x squared, e to the x times the derivative of the top, which is 2x, minus the top, which is x squared, times the derivative of the bottom, which is e to the x. I'm going to divide top and bottom by e to the x, and you would get 2x minus x squared. And on bottom, if you divide by e to the x, you just get e to the x. So it's a good answer. By the way, I'd also accept this as an answer. It is a correct answer, by the way. It's derivative. I'm going to factor that guy. What do you get? X, and then you get 2 minus x over e to the x. I'd also accept that answer. They're all equivalent to me. Which one's the best looking answer? I said the last one I put down, and let's see if we matched it. And I'm seeing it. But again, these other ones are completely acceptable to me. But let's look at number 7. And number 7 wants me to find the derivative, but they want me to evaluate the derivative at 0. So let's write this down. And what do I see? Well, I got that Leibniz notation. So dy dx. And I'm going to start to differentiate this guy. So how do you do that? Well, square the bottom. Bring the bottom to the top. Times the derivative of the top. Which of the top? 6x plus e to the x. Right? And then minus 2 to the derivative, that's 0. Minus the top, that's 3x squared. Plus e to the x. If you can't remember something, it's minus 2. I notice it looks like I'm running into another problem. Just put a little line there saying it's not that problem. Times, that's the derivative of the top, by the way. I'm sorry, I'm sorry. It's not the derivative, it's the top times the derivative of the bottom. And what's the derivative of the bottom? Fairly simple, it's 12x. Again, I'm not saying you can't simplify this guy over here, but you're losing sight of what they asked you to do. What did they ask you to do? dy dx evaluated at 0. Well, I'm thankful for the nice easy number. I'm going to plug it in. Yeah, mistakes can happen. If you plug in 0 on the bottom, what do you get? You just get 1. Nice and simple. Now let's do top. I'm going to do factor by factor and then term by term. Well, the first factor is 1. The second factor is 1. All right, minus. Let's keep going. The first factor, let's see, what would you get over there? You get minus 1. Again, I'm plugging in 0. And then what do you have there? You get 0. What do you get over here? 1 over 1, which is 1. All right, let me look at the answer. And what do they got? They got that down. They didn't put any simple form down. And again, I would say avoid that if you're evaluating a derivative, unless it's really easy to simplify it. Number 7's done. Let's go to the next page. And number 8's the last question. All right, now number 8, I say it's like, I'm going to say deja vu. It's related to the first problem we've done. So let's write this down. So this is related to the first problem we've done, which was e to the 2x. We know that guy's derivative. I'm going to write this as the product. Now, what am I going to do? Well, I've already know, I know the derivative of the first one, so I'm going to use product rule. So f prime, it's going to be the first function, which is e to the 2x, times the derivative of the second function, which is e to the x, plus the derivative of the first function, which is 2e to the 2x. I remember that very first problem we did, by the way, times the second function, e to the x. What do you get over here? E to the 3x plus 2e to the 3x. These are like terms, add their coefficients. That's 3 e to the 3x. Look at the key, and you'll see that right over here. All right. Then they say, could you guess at this one over here? By the way, guess doesn't mean you're going to be right, but I'm going to say I have some evidence at this point. So I want to put down the evidence I have. The evidence I have so far, if f of x was e to the 2x, that's the very first problem we did. F prime of x would be 2e to the 2x. So we already did this one. Now we just did this one over here. We said if f of x is equal e to the 3x, then f prime of x was 3e to the 3x. So they're not asking you to do it. They're asking you to make a guess at it. So if f of x was e to the 7x, my guess over here, that's a good guess, by the way, would be 7 e to the 7x. And that's a good guess. And that's what their guess is as well. They're asking you to make a guess, all right? Not to do it, to make a guess. And that's a good guess. All right, so I'm going to say we're done with that section over there. Certainly, what do you have to do now? And I can't say this enough times to you. You really have to try on your own. And that's something that a lot of students don't really necessarily get. They think they're going to try the night before the exam. And then when they get to the exam, they're completely befuddled and they do poorly on the exams. And that has long-term consequences, by the way, when you do poorly on exams, all right? When the long-term consequences related to school and possible career placement when you get out of school. So please put the time and effort in. It takes a lot of time and effort to do well in this class. Thank you for attending. Again, if you have any outstanding questions or concerns, please bring them to my attention during office hours.